Firstly, let me start by explaining just a little bit of background about Aemo, Australia Energy Market Operator. We operate the East Coast transmission network, and this is a very long, stringy network. It basically runs from Adelaide in South Australia, wraps around the East Coast, DC link to the island of Tasmania, and then follows the coast all the way up to far north Queensland. And that's a distance of approximately 4,500 kilometres. So it's very long and very thin, and very sparsely populated with some quite isolated load and generation centres. And for historical reasons, each state, historically each state developed its own power system, and then at a later stage the interconnections were developed. So as you can see here in the orange dots, we have each state here with relatively weak interconnections between each of those states. So that adds to the challenges of managing the network. So the demand fluctuates from a minimum of around 15 gigawatt up to 35 gigawatt overall. We run a wholesale electricity market. It's an energy market only that was established in 1998, one of the first markets, with a 5-minute generation dispatch. And we run security constrained economic dispatch with co-optimized energy and an ancillary services market as well. And you could, as you're probably aware, in Australia we've got fantastic resources in terms of wind and solar, and not surprisingly we've had significant implementation of wind and solar plant, and recently some large grid scale batteries have been deployed as well. So Aemo's role is to operate the electricity system on the East Coast, the one I was just showing. Also recently took over responsibility for the wholesale electricity market in Western Australia, and this is around the Perth region. Aemo also has a planning role. Its role is to design and operate a sustainable energy network that has to be safe and affordable energy for all Australians. And recently announced by our new CEO, Daniel Westerman, whose picture there on the screen, is that we must engineer this network to be able to operate at 100% instantaneous penetration of renewable energy by 2025. So that's frighteningly close. It's not continuous operation of renewables, but for periods of time, short periods of time, we expect we'll be hitting 100% renewable energy generation. So we need to build the power system to accommodate this. We need all the controls and simulation tools to be able to manage that evolution of the network. So one of the main initiatives that we have underway is to implement a large-scale EMT platform, ultra detailed. I think probably most people would be aware of the challenges that are presented by asynchronous plant in terms of having control systems that are software and electronics based, as opposed to the older synchronous plant, which were in some senses much easier to model. So we already have an EMT platform in place, but we found we need a system which can model the entire East Coast network in and to be able to deliver simulations in a very fast and very accurate manner. So after looking at our options, we've selected OPAL-RT, and we're currently deploying the HyperSim platform. And in fact, we've got 2 projects underway. So what's shown there in the white box at the bottom is what we call the operations simulator. This will be initially an on-premise solution. Why on-premise? That's because we see it's critical to the operation and the mission that Aemo has. So we're deploying this on-premise, and the primary function of this is to support the real-time operation of the grid. And I noted in Jean's presentation in the opening session, talking about this vision of a control center where the real-time simulation, the EMT simulation is implemented. We're not taking quite such a big step at the moment, although it's definitely a step in that direction, whereby this operation simulator will be used by teams that are not actually in the control room, but closely supporting them when incidents occur in the network. In addition to that, the system will be used for contingency analysis and other studies such as system restart. So that's one system, and the goal we have in implementing this system is that the processing time should take no longer than 3 times the simulation time. Why? I guess I can explain in a moment why it isn't actually real time, but we do have a goal for 3 times real time. So that's significantly faster than we currently have with the current platforms, which take literally hours. So basically we're reducing our execution time down from hours down to minutes. So that's the first of the 2 projects we have underway. The other project is what we call the connection simulation tool. And this is a cloud-based deployment of an EMT simulator, EMT-based simulation platform. And the idea here is that we are making available to parties external to Aemo, we're making available to them the full power system model, such that they can do studies and analysis related to the deployment of new plant, such as development of new wind farm solar. We have a fairly strict process in Australia where for the connection of new plant. This we've found there's a significant backlog in that process, and it's because developers don't actually have access to that full power system model, and accordingly they need to they tune their models as best they can. They submit their application, it's reviewed, often there's problems, it goes back to the developer, they try again, and this goes around and around in many iterations. So if I jump to the next slide, you'll see that, as I was saying, this what we call the connection simulation tool. It's basically making available the full wide area power system model, making that available, but in such a way that we preserve the confidentiality of the models, of these black box models that are embedded in the EMT models, and other protected information. Then in doing so, and by allowing developers and those applying to connect new plant, by allowing them to run studies in their own environment, in this cloud-based environment, they will fine-tune their models so that when they do come to submit them for approval, then they will hopefully take less iterations and be much faster to be approved. And one of the major challenges we have in deploying this, of course, is that it's a web-based platform. It has to adhere to the strict cybersecurity policies and patterns that we have in place at Aemo. And as you can imagine, these black box models, which are basically DLLs and lib files, so they're executables, transferring them in and out of our environment is something that we have to be very careful about. So cybersecurity is definitely a major consideration as part of this deployment. So where do we go sort of following the deployment of those 2 projects? I guess the considerations and some of the challenges we have is to have tools and systems that allow us to integrate black box models as they currently are. One of the key sort of tenets of the project that we're doing at the moment is that we take the existing models, which are currently implemented in PSCAD, And when we build up the power system model in Hypersim, we have to take those models as they are, so that we don't, sometimes the vendors don't exist, or we're not in a position to ask them to recreate the models. So we have to take them as is, and developing the tools and processes to efficiently integrate these is, a key component to the success of the project. Now that would be a whole lot easier, coming to my second point, if there was some standardized format for real code models, and there are a number of forums underway, including the joint IEEE SIGRE working group. I'm trying to remember the number, 4-82, I think it is, which are looking at the standardization of models. So if that could be adopted sometime in the near future, that would certainly make this whole process significantly easier. And a further development that we're looking at along the lines of this, what Jean called the control center in the loop, we're also looking to be able to import SCADA data to initialize the studies, such that when we do run these studies to support the operations, we have a representation that's obviously much closer to the real world state of the network. I might leave it there. That was my last slide, and hopefully that gave you a bit of an introduction to the projects we're undertaking together with OPAL-RT.